Welcome to this CyberPath Pro Explainer. You know, when organizations start panicking about post-quantum cryptography, they almost always ask the exact wrong first question. So, which algorithm do we buy? But look, as security architects, we know that is completely putting the cart before the horse. Cryptography isn't just some single software package you can easily swap out. It's literally woven into the very fabric of your enterprise. So today, we're going to bridge the gap between deep technical reality and executive business risk by actually mapping out your enterprise cryptography. We're diving deep into Layer 1, the enterprise cryptographic domains.
All right, let's dive right into this masterclass briefing. Here's our roadmap. 1. The quantum threat today. 2. Mapping the cryptographic battlefield. 3. Network and identity domains. 4. Applications and hardware anchors. 5. Securing data at rest. And finally, 6. The executive bottom line.
Section 1. The quantum threat today. Understanding the immediate danger.
We really need to establish exactly why this is an absolutely urgent problem today and not just some theoretical issue for the 2030s. The active threat right now is called Harvest Now, Decrypt Later, or HNDL. Think about it. Adversaries are actively capturing and storing your encrypted data in transit today. They're basically betting that they can unlock it the moment a capable quantum computer arrives. So if your sensitive data has long-term confidentiality requirements, say 10 or 20 years, it is already at risk. And that brings us to a pretty critical question. If nation-state adversaries are literally stealing our data today, why do we ask the wrong first question of which algorithm do we buy? Well, asking that completely ignores the reality of your infrastructure. It treats quantum risk like it's just a simple IT patch, rather than the highly distributed business risk that it actually is. Honestly, before we can migrate anything, we have to methodically map the battlefield.
Section 2. Mapping the cryptographic battlefield. Visualizing the Layer 1 container.
Before we even think about planning a migration, we absolutely must discover where cryptography actually lives. What's really interesting here is how the architecture maps the flow. It starts from your discovery targets on the left, so your applications and network transport moves through your discovery attributes in the middle and goes straight into your initial quantum risk state on the right.
To put that into perspective, right now, most enterprises are sitting right there in that quantum vulnerable state. They're heavily relying on classical RSA and elliptic curve algorithms with really short key lengths. But our target? We want to reach the quantum safe state, leveraging the new NIST standards like ML-Chem and ML-DSA. To get there, we basically need to break the entire enterprise down into 5 specific domains.
Section 3. Network and identity domains, the flow and the front door. Okay, let's start with domain 1, data in transit, or the network flow. This is your data in motion. We're talking IPsec tunnels, TLS sessions, VPNs, and your SD-WAN fabrics. This is where your cryptography is the most visible and obviously the most exposed to the public internet. Because of that, it is the absolute epicenter of the Harvest Now, Decrypt Later threat. Since attackers are scraping this traffic right now, this domain has to be your immediate priority for quantum defense.
For the architects tuning in, here is a dispatch straight from the trenches. Migrating this domain is usually all about protocol upgrades. You have to make sure your load balancers and firewalls actually support the larger key sizes and the much heavier handshakes required by these new NIST algorithms, like ML-Chem. You can't just flip a magic switch here. Your network appliances must be able to handle the actual physical overhead of post-quantum math.
Moving right along to domain 2, identity, authentication, and PKI, the front door. This is the absolute bedrock of your zero-trust architecture, digital certificates, Entra ID, things like that. It's how you prove users and machines are actually who they say they are. But here's the scary part. Quantum computers easily break the asymmetric cryptography, like RSA used here. If a quantum computer breaks your PKI, your entire identity perimeter collapses. We're talking about the risk of forged signatures, where an attacker can just completely impersonate a trusted system. Our architect's note highlights that this is often the hardest domain to migrate, mostly because certificates have incredibly long life cycles. We have to start planning for hybrid certificates right now. These are certificates containing both classical and post-quantum keys. This hybrid approach is absolutely crucial to guarantee backward compatibility and keep your lights on during a transition that is literally going to take years.
Section 4. Applications and hardware anchors, the Wild West and the physical core.
Next up, domain 3, applications and code. I like to call this the Wild West. This is where cryptography is embedded directly into the software your teams build, using open-source libraries like OpenSSL. The nightmare scenario here is the rampant use of hard-coded cryptographic functions scattered across hundreds of microservices. Applications are notoriously crypto-rigid. It's basically like welding your house keys directly into the door frame. When the algorithm breaks, the whole application breaks right along with it. To secure this domain, our architect's note says we have to enforce a standard first, customized second philosophy. Your developers must stop calling raw algorithms directly. Instead, they need to start using centralized, abstracted crypto services. You have to build cryptographic agility into the system, allowing apps to dynamically negotiate algorithms based on central policy instead of needing a massive code rewrite every single time a standard changes.
Now moving down to Domain 4, Hardware and Root of Trust, the anchor. This is the physical layer, your hardware security modules, TPMs, and cloud key management systems. This is exactly where your highest value master keys are generated and stored. Here, we're facing a real physics problem, not just a software issue. Post-quantum algorithms require significantly more memory and compute. And simply put, if the anchor is vulnerable, the entire ship sinks.
Because of this physics problem, you cannot just click Update. You absolutely must follow a specific dependency chain. Step 1. Evaluate your HSM compute capacity for the new FIPS 23 and 24 standards. Step 2. Budget and execute a hardware refresh cycle. And only then can you move to Step 3, begin your application and Layer 4 migrations. You literally have to upgrade the physical fleet before you can migrate the software that relies on it.
This architect's note highlights a massive reality check for your CFO. If your current HSM fleets lack capacity, you need to budget for a massive hardware refresh cycle before migrating applications. Keep in mind, enterprise HSMs operate on 5 to 7 year life cycles, so procurement decisions made today are going to dictate your compliance posture in 2030. That is a significant capital expenditure reality that needs to be planned for right now.
Section 5. Securing data at rest, protecting the storage vaults.
Finally, Domain 5, Data at Rest, your databases, storage area networks, and S3 buckets. This data is primarily protected by symmetric cryptography, like AES. And hey, we actually have some good news here. Grover's algorithm only delivers a square root speedup against symmetric cryptography, which means it's generally considered quantum resistant. The main action required here is simply to double your key size, moving from AES 128 up to AES 256, to keep those long-lived secrets safe.
Actually, scratch that. Don't celebrate just yet. As our final architect's note warns, the vulnerability here usually isn't the AES algorithm itself. The real danger is how those AES keys are securely transmitted and stored using highly vulnerable asymmetric methods. Think of it like this. Your vault might be made of thick steel, but if the padlock on the cabinet holding the vault key is broken, the vault itself isn't secure. You've got to ensure those key transport mechanisms are upgraded to post-quantum standards.
Section 6. The executive bottom line, the so what of cryptographic risk.
Let's pull this all together for the business leaders watching. Here is the absolute bottom line. Cryptography is not a monolithic IT problem to patch. It's a highly distributed business risk. If you just look at your IT team and say, hey, implement quantum security, they are going to fail. Why? Because upgrading an IPsec VPN requires a totally different strategy, timeline, and budget than executing a physical HSM refresh cycle or rewriting a rigid legacy application.
So I'll leave you with this provocative thought to consider. Have you actually mapped your 5 cryptographic domains, or are you still trying to solve a distributed business risk with a single software patch? Layer 1 is all about establishing scope. By breaking your enterprise down into these 5 specific domains, we take an impossible mandate and transform it into a structured, actionable roadmap. Think about that as you plan your enterprise's quantum readiness strategy. Thanks for joining us on this brief.